Thanks a lot for coming. My name's Harry. So let's say you have a successful CRM startup. Everybody likes working there. You have a lot of clients. You write code together. You're friends with the product people. You go out to lunch. You start building more and more software. You get more clients. You get a little more successful. Your code is really straightforward. You can read it. It makes sense. Everybody knows how to contribute. They get involved with it. They can make it better. After time, things get a little more complex. You start figuring out that the system needs to do more things in order to reach more people, but you keep selling it. It keeps getting more and more successful. You have more clients. You start hiring more and more product people, more and more engineers. People start contributing. After a while, it looks like this. I'll say that, we talked about a lot about different definitions of legacy software. What does that actually mean? I think a definition of legacy software is software that is a victim of its own success. So this is software that earns money for your company. You cannot live without it. It looks like this. But eventually, product has a better idea for how to make even more money, to get more clients, to make sure that you can have a better chance of success. Keep in mind, product's job is not to make your life hard. It's actually to make your life great. It's so you can get paid. It's so that you can change the world with your software. They're doing their job. They want to introduce a new feature that's going to help change the footprint of your company, and you should really pay attention to it. And a lot of times you want to, but this is how your system looks. How many people here work in legacy systems? Over 10 years old. So your house, where you live, the food you eat is largely responsible for something that looks like this, or is helped by it. So the problem is that over time, you have people come and go. Not everybody's great at documenting. Even if they are, sometimes it's lost. And you have to start coming up with sub-processes to hold things up. You have a beautiful building, but it's tilted on its side, and instead of reworking the foundation, you decide just to prop it up. And finally, there's going to be one feature that product just needs to do, and it's really good, and you should do it, and it will destroy your system. This leaves you acting like acrobats, keeping everything balancing. You're not really thinking about your job. You're thinking about, how do I not fail? And you're not thinking about, how do I design this in a more beautiful way? You're thinking about, God, I hope this doesn't drop. Welcome to Refactoring for Domain-Driven Design by not microservicing sitting in your monolith. I think there's a lot of zeitgeist right now about microservices and what they do. And they look like it's a really easy fix for a problem that's just begging for a solution. But I think knowing when to microservice is way more important than actually writing the code of a microservice. Anybody can do that nowadays. This is not hard. You can go to GitLab, you can go to Visual Studio Online, and in a matter of clicks, not even writing code, you can have a microservice CI/CD pipeline immediately without almost any investment. But I think Eric's talk, how many people were here for Eric's talk last night? So my talk is going to hover in the middle, like just to the right of hand wavy, but in very specific instances, it's going to get very prescriptive. And I want you to know that this is just my opinion. All right, it's my opinion over 20 plus years of software engineering and getting burned a lot. But it's just my opinion. Take from it what you want. But my professional opinion when to microservices starts with, do you have a strong CI/CD practice and culture? CI/CD is not necessarily about tools and technology. It's, does your CTO feel comfortable with code going from your desktop to production? Do product people feel comfortable doing that? Do you feel comfortable doing that? How much testing do you have to do? It's a huge adoption curve that a lot of people and companies aren't ready for. Think about how you deploy your monolith, your legacy code. There is so much tribal knowledge involved in deploying a monolithic system that has been in existence for over 10 years. And it's not documented. The people have to be, you have to deploy it in teams. You have to learn through failures and alerts that you did something wrong. You forgot a file, you didn't change a value, you have a connection string in some corner that no one told you about. So it's very idiosyncratic, your monolithic structure, but the problem is that you spent time learning it. And adopting a microservices architecture requires a CI/CD. It requires deploying fast. It requires changing code in flight. But you're not trained to do that, and your company isn't trained to do that. So the first decision when to go to a microservices architecture is, do you have a strong CI/CD practice and culture? Everybody's got to feel comfortable with it. If you get that, I would say the next reason to build a microservice is that it's a brand new feature in a legacy system. It doesn't have any dependencies whatsoever. You have an opportunity to not augment a current feature set or a different entity or aggregate. If we're talking about domain-driven design, it's something brand new. Maybe there's some small interop with the legacy monolith, but make sure that you're just not adding a new dimension to a current feature, because otherwise you're creating a strong intertwined dependency between your new microservice and the monolith. If 95% of the feature lives in the monolith, bite the bullet and build the monolith. Again, it's that's just my own advice. And if you're going to start introducing microservices into your system, make sure they're not vital to business flow. Make sure that business continuity is not affected if it goes down. Because you're learning how to microservice, you're learning how to CI/CD, you're not using your normal deploy patterns. No one else can help you. You're on your own. So this happens a lot. I hear this all the time. If we put it in a microservice, then everybody can use it across the system. So I don't know how this looks on this over here, but basically, this is the microservice. I've got a great idea. We're just going to put a microservice there. It's going to be security, or it's going to be a new way to think about how to initialize objects, or it's going to be something that augments all of the features there so we can have, and it's that one now critical point, single point of failure that no one's got practice with, no one else knows how to code it, no one knows where the code base might be, no one knows how to deploy it. So I'm not saying don't microservice. I'm saying when you have a monolith, you have a different pattern for when you choose to microservice. So back to the CRM. You have the CRM, it's really successful, and you want to add a new feature, but this is the type of system that you might be dealing with as far as legacy goes. Product comes along, and they say, hey, we have a customer relationship management system. We want to be able to add a preferred contact method for our customers. That sounds pretty reasonable. But we want to set a time frame for when those customers can be contacted by that method. And we want to cascade those. So this sounds like a pretty complex method for managing contacts, but obviously you can see its value, and you're like, okay, I'm going to try to code this. But let's take a look at what a legacy interface looks like. So we have a post here. It's pretty simple. This is probably the first version of what this looks like. How do you add a customer to your system? Customer ID, first name, last name, phone number, sure. Then over time, email happens. They're like, you know what, for that customer, can you just add, we just need you to add a field. Just add a field. That's all you have to do is add a field. Okay, fine, so now mobile, we need mobile. And so like this is maybe 4 years into the system. They're like, mobile is like huge now because this is the mid-90s, so we need to have a way to text people. And then social media, Facebook comes along, Twitter, everybody needs a different way to contact, and it just keeps adding. And so now we say, okay, now this business, we don't support people anymore, our customers are actually businesses because we've done so well. So now we need to separate work phone from private phone from home phone. Now we've got a lot of different things. So now we're supporting our sex, but what's happened over time is that you didn't write this code. No one you know wrote this code. You've got a lot of problems because in order to, well, let's just say this. What do you guys think this does? Same URL, right? It's a post. It's got some of the data there. This, in my opinion, sets the contact method. This is how they decided to do it. Why is it not a put? Why is it not a different URL? The answer is because it's not. Because the person who wrote it is gone. They're at a different company ruining that place. And you're left with this. And there are so many parts of your system that are entrenched with this bit of code because no one else thought to change it. So now, are you going to actually change things to make them better? Just to put a point on it, if this sets the contact method on that URL for that user, what does this do? Well, close. It deletes the Twitter handle because I didn't include it as an empty parameter, right? Everybody's like silently uncomfortable because we've seen all of this, right? This is the stuff that you inherit. And so should you build a microservice to implement that contact method, preferred contact method cascading timeframes? The answer is no, you shouldn't. Because there's so much domain knowledge in your monolith that there's no way you can extract it cleanly and not have an incredibly tight dependency between those two services. But you should DDD the heck out of it. Because domain-driven design is about tackling complexity, and you have to be able, or you have to appreciate that the people who came before you left you a very complex situation, and you should be thankful for that. Because now you get to try some really cool stuff. So there's great ways of dealing with legacy code with DDD. I think a couple times last night Eric mentioned the bubble method. If you haven't seen it, I would go watch it. All you have to do is Google Eric Evans bubble yow. And it starts at 2843. He goes through 3 really good methods of introducing a new bounded context into a legacy system. And that's great for adding new models. If you are going to add, if you have that discrete feature that's going to hang off a legacy system without a strong degree of interdependency, then this is a great thing to do. But we're not talking about that. It's not, the bubble isn't always relevant to what your feature is required, what your product folks need from a feature. We're just adding on a little bit, not a lot. And not only is all the business logic already in your legacy monolith, but it's hidden. It might be in a trigger inside your database. It could be in a stored procedure if you're lucky. It might be in different parts of different services. It may be in the UI. But it's not cleanly extractable. And they just want this one little thing to change. So we're still going to use domain-driven design, but not going to use any of the things that most people think about. Aggregates, entities, value objects, they're all super awesome. I think they're very important, but to me they're largely tactical devices to store object state. A great place to put business logic too. But if you have a distributed business logic in your system, there's no real way to get this all in one spot without a significant amount of heavy lifting. So before we get too far down, I keep bagging on like where's the service, where's the business logic. I want to talk about, again, a highly opinionated part of this talk, which is what do I think a good service would look like? Specifically, what would an ideal service, the flow of a service code look like? If I was building a service from scratch, first thing is the method signature. That parameterized method calls, I think, are evil. And they actually create bleed of logic throughout the system. The easiest thing you can do to make your system more DDDable is to have a single parameter. It's pretty easy. This is a very subtle change, but it's an important change. With a single parameter, you can test all the values as soon as it comes in. You can spend less time in your method's service method actually testing bounds. You can pass that off to a class that can actually test it for you. When parameters change, and they do when they get added, you're changing something on a class that's being passed in. You don't have to recompile. You've got issues of dependency that don't exist anymore. It's just a really nice way to start. I'll go through this, but basically, for me, my favorite way to do things is a mix between domain-driven design, hexagonal architecture, CQRS, event-driven architecture, and probably, well, I think that was about it. But hexagonal is my favorite. So just basically going through this real fast is that you have to isolate your business logic. And the business logic's isolated in the middle, which means that you have to have a translation from the client who's calling it into the business logic internal. That allows you to change the business logic or change the client without having to recompile everything and retest everything. Your business logic, once it's translated, it's executed there. You translate to your dependency model. This could be another service. This could be another database. Dependency does its job, sends it back, and then your service code can decide to emit an event. So if you're changing a username through here, you decide, okay, is this a valid username change? Is it a curse word? Is it blank? Is it too long? Send it to the database. The database does not decide if it's too long. The database doesn't decide if it's a good idea. Think of, the database just stores it. The repository just stores it. On the way back, you have an opportunity now to emit a username changed event, and then you translate back to the client model. That's just how I would do it. Again, this is the highly opinionated version. I find when I do that this code, the middle part, that service is portable. I can take that anywhere, I can test it anywhere, I can embed it in anything. As long as those contracts are solid, I have functionality that my product people enjoy, that they can rely on, that I can put anywhere. So, what do we want to do now? Is that we want to actually, we're not going to use value objects, we're not going to use entities. We're actually going to start using words, which are actually kind of, in a way, much harder. And we should get caught up in behaviors and outcomes of our system, not necessarily the aggregates and entities and the data structures underneath. When you focus on the behaviors and the outcomes of your system, the implementations are arbitrary. You start talking in terms of how things interact and what you expect from them. You begin to design by contract. And now what's really interesting is that your product people get to participate in development because you're using words. You're not talking about how things are stored in a database. You're not talking about object graphs and what's related to that. And are we using an integer? Are we using a string? What type of vector are we using? We're saying set the preferred contact method to text. Okay, yeah, the product people say that's a good idea. That's exactly what I want. And it's not easy. The second hardest thing in computer science is naming things. It's really hard. And you should spend time with your product people, not you, not your engineering friend next to you, but with the product people who want to use this. Spend time with the customer, the people actually using your product, and figure out how they describe what's going on. That's how you should be modeling your system. So when we're talking about what is your core domain and having a loose definition of it, your core domain is likely not the representation in the database. It's not the aggregates, entities, and value objects. Those are arbitrary. Those should and can change over time without the users knowing. But the external edges are what the users, the clients, are relying on. And it's the behaviors and the outcomes they expect. And that to me is more important, especially in a legacy system. If we had a talk right now about how to build greenfield applications, a lot of this talk is not applicable. You can go read a couple books, figure out how to do it on the internet, series of clicks, got your CI/CD pipeline, your startup's great. But a lot of us are in these monoliths. And part of this naming involves things like this. When you see update, you should say, we have an opportunity now to have a much more robust system. Update means that at some point in time, way in the future, it's like Star Wars, way in the past, somebody decided that they don't know how this object is going to change in the future. And so they're just going to say update anything. So they're just going to say update user, they're going to send the user object. But the problem is that if you're trying to test that as a QA professional, you now are responsible for the permutations of all the properties inside the user object, no matter what the caller is. So if the caller is a method that's changing the username, but it calls update user and passes in a user, you have to test all the permutations of the user. The name, age, rank, serial number, all that stuff. So this is not a great method name. I don't even like that one. That's a little bit better, but it's not great. Try these. Explicit. How do you test that? Pretty easily, actually. This makes a lot of sense. Are you going to send in a user class? No. You're going to send in the user ID. You're going to send in the Facebook handle. Okay, can you test that? Yeah, that's pretty easy. What is it going to do? Do I have to explain it to you? No. When should I use it? Well, it's pretty self-explanatory. You're going to make more methods if you do it this way, but it's going to be self-documenting. But it's also going to be something that's going to reflect the business needs. You can have a product person stand over your shoulder while you're writing this code, and you're going to end up with tightly congruent ideas about how this works. So when Jess is talking about business models or the middle models of a system, these are the words that people use to program their brains to start thinking about things that way. The clearer your code is, the more tightly congruent it is to the business, the more you can participate with the business, the less translation you have to do, the more congruent the business model or the models of the system are in your brain with the product people and hopefully with your customers. And now you're building a great system. Because my favorite part of domain-driven design book, Eric's book, is like the last 200 to 300 pages. It has nothing to do with value objects, it has nothing to do with entities, it has nothing to do with aggregates. It's the weird stuff at the end that no one ever digs into. This is part of domain-driven design, is storytelling. Your code should tell a story. You have an editor and a compiler that doesn't really care about the words on the screen. So instead of writing words for you, write words for your customer. Write words for your product people. Make this something that is valuable after you leave, or at least after you're working on it. If you have something that is really complex, and it's cryptic, and it's hard, and let's say you love your corporation, you love the company you're working for, and you're the only person who can understand that code, you're never going to see another part of that company. The cost of moving you will be too high. You have just become the maintainer for that system. Now, if you write code in a way where someone can say, oh, I don't know how to set the preferred method of contact of Facebook, and then they're like searching, like, oh, except for that. Yeah, okay, now I know how to do that. I'll do this. You can go do the fun part, the new things. I suggest you spend time, like maybe read domain-driven design backwards. Spend time in like the 400s, because it's super freaky and awesome. It's a lot of fun. It has nothing to do with technology. It has everything to do with culture. With how are you actually talking to people on your team, close to your team? How do you talk to the QA? Do you go to lunch with the QA folks? Do you go to lunch with the product people? Do you speak the same language? Do you get an opportunity to share your ideas? Because everybody focuses on, lots of people focus on DDD. They hear DDD, they think aggregates, value objects, entities. But that's all arbitrary, right? There's a billion ways to do that. Event sourcing is the best. But there's a lot of different ways to do it. But none of that means anything if you're not telling a story, if you're not trying to share an idea, if you're not trying to share something awesome. So, now I've laid this all out. You've got this legacy system that's got a horrible user interface or horrible API. You've got to add this new feature. You want to use domain-driven design. You can't do the aggregates. You can't do the entities. You can't change the data model because you've got about 2 or 3 weeks to actually deliver this on time. But you're tired of working in the same environment where it's just crazy and did I change this? There's a huge if-else chain for some reason in every bit of code, the stored procedures, ugh. So what do? First thing, just like I said about the method signature, is I would take all of the parameters for that incoming method, throw it into one class, right? So this is that method signature right now for the preferred method. I would just take all of them, wouldn't do anything with them. As soon as they get in, throw them into one class. Match, create a message builder, an internal message, a message builder that then you could pass in that parameterized class, and through magic, it'll figure out what it's trying to do. This is an opportunity for you to spend some time and say, okay, if this parameter is present and this parameter is not present, then that means it's a delete? Yeah, that means it's a delete. Okay, great. So I'm going to create a class that is explicitly saying what it's going to do. This is now CQRS. Command Query Responsibility Segregation. Create messages that either change state or query state. Not both. Make them explicit. Make them only change one thing. Or two things, but not a lot of things. Validate that message now. So now you have the opportunity that you never had before. Before, you're basically testing for null, you're testing for empty string, you've got a series of if-else chains that make you want to cry. Did you put a semicolon after one of the if-elses? After the paren, before the bracket? Did I do that? I don't know. That's horrible. But now you can find ways around that using object-oriented design and crazy modern software. But you basically validate this message. If I'm intending to set this as a, if I'm intending to save this, no whammy, no whammy, no whammy, awesome. If I'm intending for this message to be set mobile phone as preferred contact method, my validator can now make sure that's the case. The problem is that if there's a problem with that validation, you still can't break the contract, right? The legacy code doesn't really care that some new feature somebody added in the future has a problem. So you have to take that result, translate it to a legacy error code. But what you can do is, this is a great time, oh, I didn't put that in there. This is a great time to log. So now you have an opportunity to somehow create a correlation ID to the message and log in a modern system that, hey, I know that this update user or add customer service method was called, but it actually was trying to set a preferred method for contact, and it failed because of this. Once you get that done and you have a valid message, create a class that only does that, right? So now we've got this huge if-else chain with This allows you to extract the if-else chain, at least the pertinent information for that, extract it into a class, and make sure that it's the only thing getting done. This is partly now followers refactoring. This is really simple. And then finally, if you have a new, if it's successful, if that one class is successful with its job, you have an opportunity now to emit an event. These are just simple refactorings. This doesn't take any more time than to go in and build this system from scratch. To add in this new feature. This is a way now. Oh, translate the message to a response. So what has happened is you have embedded DDD into your system. You have started domain-driven design as a conversation between QA and product and engineering so that they can have a conversation in the future about that feature in a meaningful way. So after a while of this style of programming, you end up with a library of commands and queries. And those libraries of command and queries start describing your core domain and the bounded contexts within. A pitfall I see a lot when people try to refactor to domain-driven design, they think that the service they already had is the bounded context. And that's not always the case. Your bounded context could be spread across multiple services. It could be within multiple monoliths. But what happens is when you start seeing all of the classes that your monolith now uses for commands and queries, or those messages, you start seeing all the behaviors, you get to see where they're headed, and now you can start grouping them, right? And so instead of the classes that have just one method, in them, you say, this is clearly now a service that's meant to do this. The people who have been building this service for the last 20 years meant to do this. They designed it in a way that's not obvious but real. And so now I can take this and start building a class around it. You end up with really a Trojan horse. You didn't intend, no one intended to have a domain-driven design system behind the legacy monolith, but after a while, it's just there lurking beneath the surface. The most important thing that comes out of this method, where you're just describing the boundaries, you're not changing how the data flow works, you're not changing how anything happens beneath the curtains, behind the curtains, underneath the floor, is that you now have the ability to reason. You have the ability to understand what's going on. What does your system really do? How can we test it? How can we improve it? How can we work with product in such a way that they feel like they could code this? That's important. Can they sit down with you in the next session where you're actually going through product requirements and you just break out your IDE? And you're like, let's just do it right here. This makes sense. Can that happen? Can you go to a whiteboard and have your product person say, you know that class you used to do this? Well, what if we did this one named this? And we could see if it works the other way. You create a conversation. You also create a modular way of doing things, right? There's some really pragmatic approach to this of refactoring a system, a monolith, in such a way that you can now say, when I want to add a new feature, I do X, Y, Z, it plugs in here. I don't have to change anything crazy on the API layer. I just know how this plugs in. I've got a pattern for actually making things better over time. But I think the most important thing is it gives you a place to practice domain-driven design. Because domain-driven design is hard, and naming is already really hard. So you can now sneak domain-driven design code into production in a meaningful way and start understanding your boundaries, your contexts, your core domains. And then after a while, other people will say, what did you do? And you can go show them. And they can duplicate it, and they can understand it. And when you don't have to sit down with them to show them this does this, then that. And you can just say, hey, look, you get a message. Make sure the message is good. Give it to the service. Tell people about it. Admit the event. That's it. And so that's all. I feel like I burned through that. Tell me that was longer than 6 minutes. It's longer than 6 minutes. So, again, highly opinionated, but hope you enjoy it. If you have any questions or answers or theories, let me know. I'm here to talk.
Got some time for questions?
No questions. That was too thorough. How many people like was that off base, the legacy thing? Does that seem familiar? It's really painful. Going in, nobody likes doing it. Somebody want to share a war story? No? Everything's fine? Okay. I'm good. Thank you.
Thank you.